The Foundations of Geometry by David Hilbert.
Chapter 6, Pascal's Theorem. Section 35, the demonstration by means of the theorems of Pascal and Desargues of any theorem relating to points of intersection.
Every proposition relating to points of intersection in a plane has necessarily the form: select, first of all, an arbitrary system of points and straight lines satisfying respectively the conditions that certain ones of these points are situated on certain ones of the straight lines. If in some known manner we construct the straight lines joining the given points and determine the points of intersection of the given lines, we shall obtain finally a definite system of three straight lines, of which our proposition asserts that they all pass through the same point.
Suppose we now have a plane geometry in which all of the axioms, groups 1, 1, and 2, groups 2 through 5, are valid. According to section 17, pages 33 through 35, we may now find, by making use of a rectangular pair of axes, for each point a corresponding pair of numbers, x, y, and for each straight line a ratio of three definite numbers, u, v, w. Here the numbers x, y, u, v, w are all real numbers, of which u and v cannot both be zero. The condition showing that the given point is situated upon a given straight line, namely ux plus vy plus w equal to 0, is an equation in the ordinary sense of the word. Conversely, in the case x, y, u, v, w are numbers of the algebraic domain omega of section 9, and u and v are not both 0, we may certainly assume that each pair of numbers x, y gives a point, and that each ratio of three numbers u, v, w gives a straight line in the geometry in question. If, for all the points in straight lines which occur in connection with any theorem relating to intersections in a plane, we introduce the corresponding pairs and triples of numbers, then such a theorem asserts that a definite expression, a of p sub 1, p sub 2 through p sub r, with real coefficients and depending rationally upon certain parameters p sub 1, p sub 2 through p sub r, always vanishes as soon as we put for each of these parameters a number of the main omega considered in section 9. We conclude from this that the expression a of p sub 1, p sub 2 through p sub r must also vanish identically in accordance with the laws 7 through 12 of section 13. Since, according to section 32, Desargues' theorem holds for the geometry in question, it follows that we certainly can make use of the algebra of segments introduced in section 24, and because Pascal's theorem is equally valid in this case, the commutative law of multiplication is also. Hence, for this algebra of segments, all of the laws 7 through 12 of section 13 are valid. If we take as our axis in this new geometry of segments the coordinate axis already used and consider the unit points E and E' as suitably established, we see that the new algebra of segments is nothing else than the system of coordinates previously employed. In order to show that, for the new algebra of segments, the expression a of p sub 1, p sub 2, through p sub r vanishes identically, it is sufficient to apply the theorems of Pascal and Desargues. Consequently, we see that every proposition relative to points of intersection in the geometry in question must always, by the aid of suitably constructed auxiliary points and straight lines, turn out to be a combination of the theorems of Pascal and Desargues. Hence, for the proof of the validity of a theorem relating to points of intersection, we need not have recourse to the theorems of congruence.
The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice: this ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.